Why is it suppressed?
I think, well, we're going to have to get into a discussion on alternative history and the
Well, let's do it
alternative.
then.
Yeah, let's do
If
it.
it's involved with this, I want to know. I mean, why somebody would cut out a number in the design of a church?
My feeling is that uh, the religious architecture around the world was not originally religious architecture.
So there's this angle that is prevalent everywhere in nature, and if you look around, you'll see it too. It is everywhere from the angle of a funnel, a tornado, the acoustics of a megaphone, or what do they call those? Where the cheerleaders kind of blow it and speak louder. It's in optics. It's in our DNA. It's in the galaxy. It's in the whirlpool. It is everywhere. It's also at the top of Pyramid of Giza. So they knew about this angle. And also, for thousands of years, they were designing this angle into the tip of steeples in churches all around the world. Furthermore, not only the Catholic religion, but other religions as well. And it goes deeper. Apparently, the Russians and the United States are actually integrating this angle into their aircraft, bullets, and so on. And there's one guy who sees this angle everywhere, and he has brought it to our attention, and he wrote a book about it. And the name of the book is The Angle Itself, 76.345. Meet Charlie Ziese.
I wanted to introduce Charlie. Now, Charlie has been doing some amazing stuff with the number five, as you know, Jeff, and he has found something that, as far as I know, nobody else has found, and nobody else really bothered. And that is that there's a consistent ratio of these steeples, and there's steeples all over the world, especially in Europe, but there are some in the United States as well, and they have a certain angle, that they make. And
Yeah.
that angle is consistently related to the number five. And I don't want to steal your thunder at all, but
No, that's fine. That's
that's how
fine.
I met Charlie back at the Tesla conference
Yeah.
last summer.
Yeah.
And I've been working on the number five myself for a long time, so I was able to rattle off some numbers for him. He's not really a huge numbers guy, so he was impressed. So
Well, he
we
certainly has
formed
the
a
love for
friendship
numbers.
out
It's
of
all
that.
over his work. So, yeah.
Yeah,
Yeah. Yeah.
exactly. So
Well,
I don't
let's
want to
back.
take away from
Yeah, no,
anything you
that's
have to
good. We'll
say.
get into that's. I mean, we're going to be talking about pretty much the angle 76 point, et cetera, all
Right,
Yep.
for the next
Appreciate that.
hour,
right.
and then and then of course the golden number. But I kind of like to get to know you a little bit. So my
Yeah.
understanding is you used to work for Wall Street.
Yeah.
But
Yeah.
let's go
Yeah.
Yeah.
back even further than that. I want to get way how you got into this. Let's go way back. Uh, you live in Pennsylvania now, but where did you grow up?
Houston.
Okay.
Oh,
All right. Tell us
And
about
I
that.
I ended up uh I was dating a girl in high school, such as that dating existed with her, but we were good friends. And anyway, her mother was a widow. Her mother was dating a guy I went to Dartmouth, and so I was going to go to Rice, and I ended up going to Dartmouth. So I ended up getting my undergraduate, my MBA there. Went to Wall Street in the mid '70s, and probably the biggest claim to fame for me on Wall Street in '78. I wasn't the guy who thought up the idea of mortgage-backed securities, but I was the guy who had to put it together and make it work. So
Oh,
I
shit.
worked with the rating agencies, developed the computer programs, the stress tests, all of that
hmm.
to, to make that whole securitization industry work. And so I worked on Wall Street doing various things. I ran the credit committee for a AAA financial guarantor, but ended up in Pennsylvania because of a kind of a divorce situation and so forth. And so I've lived here ever since. I'm not with, my first wife, but I've stayed in Pennsylvania since then. So about 10 years ago, uh, I left Wall Street for good, and about 8 years ago, I saw David Wilcock's show on Gaia TV on the Russian pyramids and got interested in it. And having an undergraduate science degree, I listened to all of the research with great interest, not understanding how geometry could create these effects, these health effects, free energy effects, and so forth that seem to be showing up in the Russian pyramid research. So that's kind of how I got into it. And one thing led to another, and wrote a book a couple of years ago, started developing, seeing other relationships with fractals and the torus and so forth. And actually kind of came up with a model that seems to bring the math and geometry of a toroidal-based scaling mechanism using the Fibonacci series also as the driver. It works perfectly to scale both positively and negatively when you're using the golden ratio. So, we can get into that too, but
Yeah, let's
that's
get into
research.
that. Let's go ahead. I want to get some background here on the math really quick.
Yeah.
So the gold, I call this the golden number, and I like your take on it. The reason I do is because it, as many different equations as you can apply it to, has many different definitions. So Euclid called it the extreme and mean ratio or something like that. There's others, the golden ratio, but it also can be thought of as an analogy. So A plus B is to A as A is to B. So what fundamental definition of phi or 1.618 so on do you subscribe to, or is it just all of the above?
Well, it's a little bit of all of the above. I mean, I guess I've gone through, I mean, I don't want to, when I say these things as fact, I'm not degrading other researchers here, but for example, Nassim Haramein, I don't, he and Dan Winter both figured out that the universe was scaled with the golden ratio, but neither one of them came up with how did it happen kind of thing. And part of the reason, I think, Nassim, he did a movie documentary about 6 years ago called The Black Hole, I think, and it's on Gaia. But there he seems like he's saying that you can only achieve this concept of phi convergence if you're familiar with that phenomenon through using 0 and 1 as the first two number values in the Fibonacci series. Are you familiar with that process, how it works?
I am, but can we use a clip from
Like,
your video to show it? I have it pulled up where you actually break it down. Can we show
yeah,
it?
sure,
All right.
sure. Now, what is the golden ratio itself, or phi? The golden ratio, or phi, in shorthand, is defined as the relationship between two or more objects such that, and let's look at the box here, A plus B, in other words, the length of this entire line is to A, the larger part, as A, the larger part, is to B, the smaller part. These are relationships that stay constant. And the golden ratio, or phi, is the only solution that makes that relationship work. And that's what makes the golden ratio nature's natural scaling ratio. Now, the golden ratio, or phi, is not a real number. In fact, it's an infinite irrational number. But rather than considering it as a number, we should consider it as a relationship, which we approximate as 1.6180339 and so forth at the bottom of the page, which is approximately equal to phi, or the golden ratio itself. So we'll be talking a lot more about this. So I wanted to make sure that everyone got at least a basic knowledge of what the golden ratio is all about. Nature's natural scaling ratio. Now, what is three-dimensional phi scaling?
All right, we're gonna
Well, you
stop you
can
there.
see up here at the top.
That's the basics of phi, and I thought that was the clip of the Fibonacci sequence. But
Yeah,
if you could, it was somewhere in the around that area. So
yeah.
if you could, Charlie, please explain then the Fibonacci sequence and how it relates to that number.
Okay, so again, to go back, we've got that series of numbers 0 and 1, 1, 2, 3. So if we take the first two numbers, we can't divide by 0, so we'll discard that for a moment. But if we take the second and
One
third,
second. Explain why that sequence comes to rise. It's because we add the previous one.
that's right.
So,
So we're
0 and
0
1,
and
you add those
1.
together, you get 1. So then you
Yep.
have 0, 1, 1, and then you add the 1 and the 1, and you get 2. So 0, 1, 1, 2, and you add 1, 2, 1 plus 2, and you get 3. And it keeps going up, adding the last 2. I just want to make sure that we
Yeah.
got that in there.
So
Okay.
now that we've got that set of numbers, now let's take the first one, the second one, and divide it by the first one. We get 1. So
Mhm.
keep that one in mind. Then we take 2 and divide it by 1, and we get 2. Now 1 is below phi, and 2 is above phi, because we know phi is approximately 1.618. Now 1 is further away from it than 2 is from 1.618, so we've gotten closer, but we're above it this time, not below. Now the next time we're going to divide 3 by 2, and we're going to get 1.5. So now we're below the Fibonacci phi, but we're even closer again. So we keep doing that. We're going to find that we alternate going above and below it, but each time that approximation gets closer and closer. Now, what Nassim seemed to be indicating in his
And who is
film,
this gentleman?
Nassim Haramein, he's
Don't
a
know him.
okay. Well, he's a leading kind of non-traditional quantum physicist who
Okay.
has worked a lot with the torus and has worked a lot with Foster Gamble. He was in the
Mhm.
Thrive movies, 10, 12 years ago.
Yep.
And so,
Nassim also spoke at Tesla Tech years ago.
okay. Yeah. So Nassim he also has a nonprofit called the Resonant Science Foundation, which I think has now morphed into some other entity like the International Space Federation. It sounds quite profound, but anyway, since Nassim and Dan Winter are both people who have, kind of in their own way shown that the world is scaled in phi, for him to kind of miss this, I think he missed the fact that the Fibonacci series, along with this idea of successive divisions, will always, any two number pairs will result in this convergence phenomenon. You can take positive numbers to start with. You can take negative numbers, positive and negative numbers. It doesn't matter. I've done some research, and no matter what two numbers you start with, by about the 24th iteration, you're at exactly the same precision out to 8 decimal points to achieve phi. So the phenomenon is universal. And even though, if you can think of a cupola, this is where I'd love to take the research next. You know how it kind of curves at the bottom. I think that is perhaps indicative of this process as well, that as you get more precise, that angle becomes more and more precise as you go further into the process.
All right, so
So
can we do an example somehow? Maybe I can grab a calculator and we just grab a couple numbers and
I
start going.
can well, let's see.
I got Wolfram Alpha. I can pull it up and we can just kind of start adding.
I've got examples if you want to see
Yeah,
them.
we
Yeah,
can
go
make
ahead
an
and share
Excel
your
sheet.
screen.
Yeah, it may take me a second to get there, but I'll pull them up. Can you guys see my screen?
Yeah,
I
we
sure
see it very
can.
well.
Okay. All right, good. Because I minimize this. This is something I did a couple of weeks ago out in Cincinnati at their expo, but let me put it into slideshow so you can see this. All right, so this is kind of fascinating stuff from my perspective. So what I've done, I've just taken two sets of initial number pairs, and the yellow group is the classic 0 and 1.
Mm-hmm.
And what I've done here is just done a bunch of iterations. Let's see, there we go. 0 and 1 produces 1, 1 and 1 is 2, and so forth. So that is the series that we develop in the left column, and then the right column are the ratios, and you can see the achievement of this phi convergence phenomenon. You start with 1, and then it goes to 2, 1.5, 1.66, 1.60, and so forth. So you just get successive approximations which become closer and closer to 5. Now, what I did here to show you that Nassim's assumption is just not correct, I took a number of different initial number pairs. Here's one with 1 and a billion or million in it, a billion, sorry. And you can see what's interesting, even though we have different numbers, the ratio itself, if you will notice, it matches perfectly to 8 significant digits, exactly what we got when we started with the number pair 0 and 1, which,
Well, those two do because you're just adding it at the very end of a million or a billion. But
well,
I'm
you're
interested
starting
in-
with 0 and 1 and 1.
Right.
But anyway, yeah.
The next one though is fascinating.
Well,
I
there
like
you
this.
go.
Yeah, so let's look
500.
at this one.
Yeah.
500 and minus 50. This is when it starts getting interesting because it really breaks into it. Okay.
But you can see that they all get down to like 8 significant digits, no matter where you start. In minus 50, you can start with 2 negative numbers.
Right. Rapid convergence.
Yeah,
Good.
very rapid convergence. So now that's half of the equation. The other half is if you were to use this with a multiplication or division, it wouldn't work. You have to use addition and subtraction in order to make this work. And that's why the golden ratio is so important in scaling. But you can take those very same numbers that we developed on the preceding page. You'll see you can't see the bottom of it, but those were the 46,368 and the 28,657 were the last 2 numbers that we got. I see it's chopped off, but you can see that you just reverse the process and you end up exactly back where you were before. So you can scale upwards or downwards perfectly with the Fibonacci series coupled with the, I don't know what else to call it. Greg, what would you call it? But the kind of the recursive, formula for achieving phi convergence, the successive divisions. So,
All right, good.
Same thing in reverse.
All right.
I'm still a little unclear about what it is that you say Nassim didn't get right. Because
Nassim thought that you could only start with the initial number pairs of 0.
oh, okay, yes, you're correct. It doesn't matter what you start with; it's the process.
Yeah, but
that,
if you
that
go
gives
back
you that ratio. Yes,
you go
you're
back
right.
and you listen to that.
I thought he was saying the opposite, and you were questioning that.
No, he says that
You
0
got it
and 1
right.
work,
Right.
but he said that only 0 and 1 work.
Yeah.
To achieve that convergence.
Did he ever test any of the other ones?
I don't know. Anyway.
Thing. All right, so I have a question then, and then Greg and John jump in with some questions before we move on to the next. But I did have a question about this. As you mentioned in that beginning introduction, sacred geometry. I'm just wondering math is beautiful and creation is sacred, but what is the difference between I don't know, a golden pyramid and an isosceles, a triangle? I mean, is one sinful? I mean, what makes one sacred and the other one not?
I don't know where. Greg and I have
the same
talked
question.
about this. I don't know where that term came from.
Okay.
And we've talked about definitions of it. Everybody's going to have a different idea, but I'm going to say that when it comes to scaling, the golden ratio is the key. And so my simplistic answer to that is that wherever I see the golden ratio, I perceive that as being part of sacred geometry. That doesn't make my definition right, but that's kind of the way I look at it.
Okay.
Jeff, I do have an answer for that question because
Yes.
I've asked the same one.
Others
The
people-
answer is that the term sacred geometry really comes from the Jewish Kabbalah or Kabbalah. However you want to
really?
pronounce it.
Okay.
Yes, that's where it comes from. So it's very old.
I
Been around
see.
for
Okay.
millennia. But they have an idea that certain shapes, have a mystical power or influence or whatever, and that they invented the term sacred geometry to express that.
Isolate
So,
that one.
Ultimately, you want to go back to the root of it. That's where it comes from.
All right, I have some stuff on but I'm going to save it for much later because I want to hear everything. Make sure that he doesn't cover it already because this is neat stuff. John, do you have anything, or Greg,
As
questions for Charlie before we go on? I'll make sure everyone's
Not at
going
this
following
moment.
as we go. Okay. All right.
No, that's good stuff. You go ahead, Jeff,
All right.
Well,
or Charlie.
well, maybe we can show some. Do you have anything else to say about that? Because you have 5.5 hour documentary, or it's kind of
Yeah.
like kind of like a conference presentation. And it would have been a 5.5 hour one because it's kind of presented that way, and I like it. I want to see. I want to show. You have like a lot of sections, and we can't go over all of them. But there was some cathedrals. I like, and so I kind of like to look at some of the cathedrals, and you can discuss this angle, the 76 degree. What was the exact number of the angle? It comes up a lot in my work when I
Yes.
was doing the
It does.
yeah, so
76.345
three,
dot
four,
dot
five.
dot.
That's right.
Can
That's right.
can I make a plug here for Charlie?
Yeah.
As far as I know, Charlie's book is the only book in existence that has an angle as the title.
Nice.
I don't think
Nice.
any other, is there a book called 45 Degrees or something like that?
I don't think so.
6 degrees of separation.
Yeah,
Yeah.
well, that's close, but that's
Yeah.
not the same.
No, they added words to it, and
Show
all
it
right,
up. That's
yeah.
the name of the book.
I even got on, I didn't, my name didn't, but Cliff High mentioned, do you guys know Cliff High?
Yeah, of course.
He
I'm
was talking
not
about
familiar with
phi
him.
last Wednesday and talking about 76.345.
Yeah.
So I wrote him. I don't know
Yeah.
if I'll hear back.
Of course,
but-
you didn't invent the angle. I just want to be clear on that, but
Oh,
you did,
no,
you
no.
did write the book.
But I did write the book. That's right. That's right.
He is God. He created the angle himself, even. Sacred gem. Let's go and dig into. I think I got some. Yeah, 25-minute point. There's some neat things. Let me go and look at that.
Can we show that book? I don't want to mess you up too much, Jeff, but
Well, wait till
When we get to it, we'll
yeah,
show the
once
book,
once
yeah.
we after I shut the
Might
video
wanna
up
see it.
because otherwise I can't do two things at the same time. All right, let's see.
Glad
Give
to
me a
be
second to
So,
find the
This is
25
actually
minute
the
point.
macro level where we're finding this geometry.
Oh,
but
it
it's
is here. All right.
It's the source of all creation, according to most theorists. Um,
Really quick before we start this, this is not the section on the steeples. We'll get to. I got like 5 different times that I like this. This is really interesting because he covers how this angle comes up in sound, in optics, in tornadoes, nature. So this one's pretty interesting, and then we can ask some questions about that. I like this one.
that you get a 76.345 degree angle of refraction. In the next example, we can't see sound, but we know that sound is amplified by a megaphone, which has this exact geometry. We see a water funnel here of a water vortex, which has this angle, and we see it as well in our DNA. And it's not only in the macro structure of the DNA that we're depicting here, but you'll find this Fibonacci sequence, this phi convergence, occurring within the microtubules inside the DNA. So this is actually the macro level where we're finding this geometry, but it also exists down in levels that we can't really measure, but we can quantify by using the Fibonacci sequence.
Charlie, can I just throw in my 2 cents? I'm looking at that
Now
funnel.
here is some
Oh, I'm
other
sorry.
examples.
There's a
that
video plan. There's a video
Sorry.
plan.
I didn't realize that wasn't Charlie.
Greg didn't
talking.
have his coffee today. All right, let's pause it and ask some questions. Go
sorry.
ahead. That's okay. Well, let me stop screen share. We'll come right back to it because I want to hear your question. He thought the video.
It sounds just like you.
I know.
Because
I
and
recognized
the
it
background's
first
the
time.
same too.
Yeah, exactly.
Yeah,
So-
yeah.
All right, go ahead, Greg.
I bet I'm not the only one who thought you were actually talking, Charlie. So,
No.
well, my question is this: I really like the tunnel, but that didn't look like it was 76 degrees. That looked much smaller to me, and also it kind of
Oh, well-
fanned out, so the angle actually changed. It wasn't a constant angle,
Well,
just for whatever that's worth.
yeah, I mean, the angle on the base is 76. At the
Okay.
top, it's 27. So 27,309 is kind of like the top version of that. So
Okay.
what I was measuring was the 27-degree angle of the
Yes.
tunnel going upwards.
Yes,
So
yes.
it's just
And
inverted.
at the apex, is it always 27? Like this is
No,
this is- it could be
tornadoes develop, they have a growth phase and then a degradation phase. So you have to catch them right in the middle in their mature phase to find that angle as with
Okay.
precision. And
But you think all tornadoes, when they're ripe, as it were, are going to have that angle?
I have about
Pretty
50
much?
examples of it.
Wow.
Yeah. Yeah. So
Wow.
I think that it is. Yeah.
That's
Yeah.
what
Would you say
nature
that it's
does.
the most stable period of the tornado's existence
Right.
that has that angle?
The most
So
mature.
it
Yeah.
seems like that's also an ideal, a limit that it's trying to get to,
Right.
some
And
sort of self-reinforcement mechanism of it.
Hmm.
And
Okay.
the same thing seems to be true with water vortices as well. And if you have them inside of, let's say, a glass tube where you can visualize it, if you've got it kind of revved up to the max, then you're going to get this geometry. If you don't have it revved up to the max, you won't. So there's something there. Then we get
Okay.
into fluid dynamics, and it's everywhere in fluid dynamics. So
Right.
it's the angle that minimizes the drag coefficient for in any fluid dynamics environment. So
There's-
27 degrees is another one. It's
that's the one. Yeah, that's
it's not the complement of 76, because that would be 24.
7309.
It's a different, no, it's a different angle related to the series of, we don't need to get into details, but it's one of the,
thing. Yeah.
Yeah.
So the 27-degree angle shows up in all fluid dynamics. So there's clearly it's significant. And of course, then we see this same geometry, at least it's showing up in the Russian pyramids. It shows up in Victor Schauberger's water imploder. It shows up in Wardenclyffe Tower, and so on. So,
in what way does it show up in Wardenclyffe Tower? Because I always envisioned a ball where everything's kind of going all everywhere.
It's the angle of the actual thing.
Oh,
now,
the Wardenclyffe Tower was built with that angle.
Yeah, the tower is built with that angle.
So Tesla thought it was important.
Apparently, yeah. Now, we've been talking about, and I don't want to digress, but I mean, the idea is this fundamental to structural integrity? Does it help? And I think the answer could definitely be yes. But then again, that would just be sort of a complement to everything else. If it works in fluid dynamics, maybe it's going to work to help support structures too. Don't know.
Yeah.
But I have done some more research on structures, Greg, just in the last 3 or 4 weeks, and I have found it in all of these angles in any number of architectural contexts. So maybe there's something there too, but I don't think it's one or the other. I think it all kind of fits into a model that tends to, Erlenmeyer, Emil Erlenmeyer, he's the inventor of the Erlenmeyer
flask. Any chemist would know.
It sounds like a footnote, but that flask has that geometry.
Interesting.
And so people say that flask seems to help to create chemical reactions more effectively. But he was also known as the father of, or was one of the theory of structure. Now, I don't know if you guys know what that is. I've tried to find it out, but when you look up Emil Erlenmeyer, it says theory of structure. Well, that's something to do with architecture. So there may be, there's probably.
Or it could be, since he was a chemist, Lewis structures were the organization of atoms on the outer shell. I don't know. Wasn't he about the same time as Lewis structures?
Could be.
Erlenmeyer?
Yeah.
I'll look that up.
Yeah, I don't know. So, but there's a whole bunch of stuff there.
All right, so couple questions on the numbers because I'm fascinated with it. 76.345 degrees is roughly 1.3 something radians, and I had a spreadsheet of all of these, where everything connected to the golden number. What is that relation? If you don't know, that's okay. I have it written down, but I don't remember. I was trying to recalculate it. Relation to pi and radians, like it's what is it? I don't know.
I don't know.
Okay, that's fine. And then that angle, how does that angle directly connect to 1.618034?
Okay, yeah. Let me tell you how I devised the whole geometry.
Mm-hmm.
I knew that Golod, the Dr. Alexander Golod was the head of the research on the Russian pyramids. And that's what this is really re-engineered off of, is he said that the golden ratio was involved in the geometry of these pyramids. Well, I knew that it was close to 76.3 degrees. It's about as close as, without numbers to back it up. But what I did was I took in 2 dimensions. Let's do it in 2 dimensions because you can go to 3 real simple. If you take a circle with a diameter of 1, and then you start to stack circles on top of it, each time the new circle above it, you're going to take the previous diameter and divide it by the golden ratio.
Okay.
So
That's where it was. Yes. All right. So this is awesome. This is exactly what I found with Riemann oscillator. I had an angle here, and I was stacking up spheres, and I had different sizes, and it was going up, and I took that angle. That's where the angle was coming from.
Yep.
That is fascinating. And I got to let go of it. We didn't use that in the paper because instead I inverted something to give a better, to get phi as a straight line. But keep going. I know exactly now the angle is.
So
Keep
that's
going.
it. It's just stacking circles whose diameters decrease.
Wow. Do you have an image? Do you have an image of
Build a
that?
triangle around it, and you got it.
Do you have a image in your slides? I'd love to see that because I want to.
Sure.
I'm going to contact you. I'm going to show you my image. I have it in a 3D CAD. It's exactly
no
that.
problem.
That's amazing.
Let's go.
Okay.
Let's go back to it. Oh, I can show you phi convergence now that I'm in here too. So
Okay.
I mean,
There's your pyramids. Yeah, I just saw that.
yeah, there it is. Okay, here's phi convergence. Can you see this diagram here?
Yes, going up
Yes.
and down.
Yeah,
Yeah.
you can see that's it graphed. Let's see where this. Here we go. Right here.
Yep.
So
Okay.
all I did was to start with a circle with a diameter of 1 and then stack
Yep.
them 618, 382, 236. You can do that ad infinitum, and you'll never get to the top of the pyramid. And it just all scales. And the slant angle at the base of this is 76.345, and the apex angle is 27.309.
Okay, I was doing the exact opposite. I was doing it between this angle to the point of real part 1/2 and I'll start with a small circle there and then multiplying it by that ratio, and it gives that angle. But it's the same thing, it's just in reverse.
Yeah.
Okay, interesting. Very, very cool.
Yeah.
All right. Anyone else have a question before I go to the next video clip?
Well, I have a couple things that we've been moving ahead so fast. But I did say I was going to look up the Erlenmeyer theory of structure, and
Yeah.
it is related to chemistry, although it's long before Lewis structures. There was something called the Erlenmeyer rule, and the site I'm looking at states that the chemical compounds have more than one hydroxyl group, that is the OH on a carbon atom, are not stable. So that's the Erlenmeyer rule in a nutshell. Anyway, substances with 2 or 3 or 4 hydroxyl groups are generally unstable. So it had something to do, the theory of structure. There isn't like a Wikipedia page on the theory of structure, but it does mention it. And I
Right.
think it was an early version of what Lewis later came up with, which was the idea of how do compounds come together? Why do they form in certain ways?
Yeah.
And he was much before that. I think he was born in 1830, something like that, 1825. So yeah, he was before the time of Gilbert Lewis. Anyway, I don't know if that's, so yeah, it was having to do with chemistry.
Okay.
Doesn't
Well,
mention anything about phi in what I'm reading though.
no, well, no, and it didn't for me either, whenever I researched it. But the one thing also that's important, the particular bonding mechanisms that he discovered was how to devise double bonds in certain chemical compounds.
Yeah.
Well, that's I'm just theorizing here, but if Dan Winter has now kind of accepted this model and this geometry for his implosion model, and you get ionization as the first thing here, but is this a way to is the geometry one way to make these double bonds more, to increase the energy that's contained in those molecules? I don't know. I'm just throwing it out.
Yeah. Yeah, no, this whole idea of double bonds and stuff like that, that was a major league issue in the 19th century, the 1800s. They were still trying to figure out, that hydrogen has a double, H2 and O2 and all these things that came in twos, and it was the molecules that would bind to each other, going back to Avogadro. That was really an insight to these people, and I think Erlenmeyer was part of that.
Yeah.
Anyway, that's what I gathered from what I looked at. Also, Jeff, I know this was
Yeah.
a while ago, but oh shoot, I lost it now. You asked the question, is somehow the angle related to the golden ratio? And the answer is yes, there is something called the golden mean, or the golden angle, which shows up a lot in just like the way leaves inform, they won't go like, there won't be one leaf here and another leaf 180 degrees. It'll actually be about 137 degrees off, and then the third one will be 137 off of that. 137. That number 137 degrees is the angle that leaves choose to the next one will grow from. And we've seen this same phenomena, this 137 and a half degrees. That is precisely 360 divided by the number 5, actually 2.618.
360 divided by 2 phi.
Yeah, which is phi squared.
Got it.
Or you could just take 360 divided by phi and you get the complement of it, which is.
All right, then it's very easy to
360.
figure out what the relationship is to pi
Yeah,
in
that's
radians.
called
Got
the
it.
golden angle.
All right, good.
It's a very important part of this, but not
Yes,
not necessarily
no.
part of Charlie's work. But
So you documented a large number of structures going way back into ancient, some which I'd like to get into, which are possibly 130,000 years ago. But let's start more modern with a particular church steeple that I really like these. Not these. Hold on, it's after this. All right, these.
Staff churches are a type of wooden church built in Northern Europe between 800 and 1200 CE. In the mid-14th century, construction abruptly ceased, roughly corresponding to the end of the Middle Ages and the suppression of instruction in the quadrivium. About 30 staff churches survive in Norway, nearly all dating from the 12th and 13th century. Sweden, Poland, and English each have one of these churches, and in addition, 2 replicas of staff churches have been constructed in the United States, one in Minnesota and one in South Dakota.
All right.
Neo-Gothic is an
Let's-
architectural movement that began in
I grabbed those for 2 reasons. One, because they're really interesting looking, simple churches, but very beautiful. You mentioned also that that this methodology was suppressed. Why is it suppressed?
I think, well, we're going to have to get into a discussion on alternative history and the
Well, let's do it
alternative-
then.
Yeah, let's do
If
it.
it's involved with this, I want to know. I mean, why somebody would cut out a number in the design of a church?
My feeling is that the religious architecture around the world was not originally religious architecture. I think that the existence of this geometry tells me, along with the other antiquitech that we see, the antennas and the balls that probably contain mercury. We've got a lot of things that make you think that these were either potentially energy, power plants of some sort, or healing centers of some sort.
What
But
makes you think that?
Well, once you get into sound healing and for example, we can't build these organs today that were, in these Gothic cathedrals. And I think that the harmonics of the geometry in these buildings was such that you could probably achieve a real sense of health and well-being from being in there. But I also think that there's plenty. There are free energy temples. There's one that's in Phnom Penh, Cambodia right now that still produces free energy. It was built in the 1860s, and it's got a coil on the top of it with this very geometry to it.
All right,
So
if I may, I'm losing you, and I don't want to because this is really interesting. This is the most interesting part of it, and I don't want to miss anything.
yeah,
Who wanted to stop having churches be healthier in 500 years ago? Is that what you're
I
saying, or because I mean,
no,
you
I
or
You're
you go
saying
way
the
back to the
all right.
origination
yeah.
Let's okay.
religion
Let me
versus the
yeah.
Pope.
Let me try to pull all the pieces together, at least at the beginning of the 16th century, because that's where all of this seems to have occurred.
Okay.
The quadrivium stopped being taught. The Gothic cathedrals stopped being built. And then most importantly, in the starting around 1530, I think, there was an event called the Council of Trent,
I'm familiar with
Trent.
it, very familiar
It's in
with
the
it.
And
1500s.
Joseph Scaliger is or was a priest who wrote a chronology of the history of the world that was adopted by the Council of Trent as the official history of the world. But it was, as it turns out, well, this is all based upon research done again in Russia by, oh gosh, what's his name? Uh, Bear with me.
Hmm.
Anatoly Fomenko, Fomenko.
Okay.
And he did a 7-volume series that's called The New Chronology. But what he's done is to document that so much of our history is not in alignment with reality. The way he found this was through science, actually. There was an American scientist in the 1970s whose name escapes me, but he wrote an article that said that he went back and looked at the eclipses that were to have occurred during certain time periods as stated in our chronology, and they didn't fit. They didn't match up. And Fomenko remembered an article that he had read by a fellow Russian that had been written earlier in the century that made it look like, in fact, there was like a missing 1,000-year period in our chronology. And so he went back and did the same calculations based upon the chronology that he found in this article, and sure enough, everything matched up. So that started a 50-year study of his to document all of the inaccuracies in our chronology, the fact that what we take as ancient Greek history, those people may have in fact been contemporaries. You just, once you start to go through and analyze it, you realize that there's a lot of questions that are left unanswered in our chronology. So something significant happened there. But now the most important question from my simple-minded point of view is the Church of England, the Lutheran Church, and the Catholic Church, much less all of the Eastern Orthodox churches, all have these cathedrals with this geometry in it, and they have no research whatsoever on the geometry or the architecture of those steeples. Now, how can that be unless there was an attempt to purposefully lose that information? I think that would be an extremely challenging thing to do.
All right, I like this. All right, so let me see if I can summarize. So the Council of Trent, I understand how that came to be. It came to deal with new sciences that were coming up, namely astronomy. And so they had to figure out, they had to take a position and all of these things. And so you're saying that, and I didn't hear about this guy's name. So his job was to go and say, okay, what is
Joseph Scaliger?
Scaliger? I have heard that name. All right, so there, your job is to go say you're going to document how old the Earth is, and this is our church's stance on it, and this, and then maybe you're possibly theorizing that maybe around that time they came to the conclusion, well, how are we going to justify this timeline if we have these, we keep promoting these ancient churches that go back way beyond our timeline, like way beyond the 10,000 years old that the civilization is, that the earth is created. Is that what you're kind of saying? I mean, don't be
That's-
shy if that's what you're
Yeah,
saying.
no, that's
Okay.
exactly it.
All right.
For example, we have never found the original works of Plato. They've never been found, ostensibly. However, or we don't have copies of them today. Let me put it that way.
The originals, you mean?
But in the 16th century, there was a guy named Plotinus, sounds a lot like Plato, who comes up with all this information.
Okay, so
And-
there's a second Plato, an imposter. This is cool. I never heard this one. All right,
Yeah,
go on, keep
Plotinus.
going.
Look up
I
Plotinus.
thought it was Plotinus, but yes.
Plotinus.
I don't
All
know,
right.
however you
Maybe-
say it. I don't know. Maybe it's
I like
Plotinus.
Plotinus.
Yeah, maybe it is Plotinus. but
Platinus.
I don't know. I don't know. But anyway,
Go
so,
ahead.
so I mean, that's a theory.
Plato, it's
You-
very
with-
similar. You're right.
If you
Well,
go
Plotinus was a playwright in the ancient Greeks. So
Was this a
am
real
I-
person,
This
Plotinus?
is a different person, not the same guy.
this was a 16th century person.
Okay.
Yeah.
All right, that's not the guy I'm thinking of. Okay.
Well, and see, that's the point. Some of the ancient Greek historians, there are pictures in, I have only read the first volume of this book, of this 7-part
What's the name of
series.
the book? What's the series?
Well, it's, let me pull it up. I'll get it for you on Amazon.
Oh, Greg can pull it up. Maybe
Well,
Greg can
yeah,
look that up
I
while
have a
he's
lot
talking.
to share actually since we since
Yeah,
our last
so-
talk.
Yeah,
But
this is interesting.
okay,
This
I
is
don't know who this
revisionism.
Plotinus guy is from the 16th century, but there was a playwright, very famous playwright. You know, he's right up there with Euripides and Sophocles and those guys. Not maybe like the next tier below that would
Yeah,
be
yeah.
Plotinus. But maybe it is
maybe it's
Plotinus.
Plotinus. Maybe Plotinus. Yeah.
I'm looking at it. It looks like
Plotinus, maybe.
Plotinus. I don't know. No, it is Plotinus. I'm looking
Okay,
at the
Plotinus.
thing.
Okay.
Plotinus.
But I don't know if that's the guy from the 16th century. It could be another guy with the same name,
Yeah.
obviously.
It probably is. The
But
playwright versus-
I hope this isn't going too far off the track, but I did some digging on Anatoly Fomenko you mentioned.
Yes.
Is it okay if I bring that back up?
Yeah,
That was
let's
like
definitely
5
let's
minutes
talk
ago.
about. Yeah, I want to. I know what
Jeff,
that-
you'll be fascinated. This guy is a real polymath. He's 79 years old, he's a professor at Moscow State University, and he was born in Ukraine, which at the time was part of the Soviet Union.
Right.
So
And
that's right.
just a little plug there. Most of you, at least half of you, what we call Ukraine today, was part of
That's
Russia.
right. That's right.
So anyway, but he's a mathematician, a conspiracy theorist. This is according to Wikipedia.
Of course, they
Wikipedia.
have to get
Is
that
there-
conspiracy.
They have to say, and
Is
he's
there a
got
way we can get
pseudoscientific
in contact
history.
with him?
That's
Is
what
this-
I think. But here's what you're going to love, Jeff.
Yeah.
Is he's done quite a bit of work on
With the Riemann
Riemannian
hypothesis.
manifolds.
Oh,
and
manifold.
higher geometry and
Interesting. Yes.
topology.
Let's
Those are
get
his
him on.
areas.
Yes.
So,
definitely.
fascinating guy all around. That's nothing to do with necessarily what we're talking about today, but I think it'd be somebody you might want to follow up on.
Yeah, we'll table that.
Yeah,
yeah.
definitely.
Yeah.
Okay.
Anyway,
Another
Yeah,
rabbit
sorry.
hole.
All right. Now, so are you suggesting then that Plato didn't exist, or he existed
No,
as a
he-
historical
Well,
figure, but we
I-
didn't have.
all I'm
his
saying
work?
is I don't take anything, Jeff, at face value anymore.
Right. No, I know it's hard. to
So
anyway.
I now say that the quadrivium is information attributed to Plato. I don't know that Plato existed or wrote it, but the information seems to be very valid and accurate. So where did it come from? One of the ancient Greek historians, if you go into volume 1 of that book, there are drawings, Aurelius, I think, something like that. I don't remember. But anyway, some of these ancient Greeks were actually contemporaries in the pictures that are drawn of 16th century, Europeans. So you have to get into the book. I don't want to sit here and try to say whether absolutely something happened or not, but there seems to be a lot of confluences of a number of events, and such as the ones I'm talking about, that tend to make me think there was something major that changed in that time frame.
All right. I definitely think I can buy. Not that we really care about my opinion, but I am going to state my opinion anyway because I think this is what I think. All right. So I think that definitely there was something to shut off this old heresy that we should be impregnating into our church steeples. I believe that there was definitely a push for that because that's right around the timeline when the church was thinking that way. But I tend to think that the Plato's documents just were copied and handed down over the generations. Because the moment that people started saying, not the moment, 500 years later, people were saying that the Apocrypha from, the Old Testament didn't exist. All of a sudden it turns up as in the Dead Sea Scrolls, and sure enough, they did have original copies way back when. So I do believe that a lot of paper and parchment things get burnt and they copy it as they go. Because Plato, some of the stuff Plato came up with would be, there's a lot of math that follows it. So how, if Plato came after, it wouldn't make sense how people, had the quadratic equation years before that. You know what I mean? So I'm of the school that Plato was a real guy that lived somewhere around, was it 400 BC? We don't have his original
Golden age.
writings, but I think they might show up somewhere in some vault. But
It's just that there's too many things, and the fact that we don't know about this, we lost it somewhere between then and now. I just think there had to have been some kind of an event.
Well,
yeah.
can I throw in my 2 cents? And that is
Coordinated,
that a
coordinated
lot of these
effort.
works were held in the libraries at Constantinople and that was one, Alexandria was one.
Right.
Caesar burned Alexandria's library,
all
so
that
that
went down.
wasn't available to us, but the library at Constantinople was. And when it was sacked in 1453 by the Turks, I mean the Ottomans, then they preserved a lot of those documents and brought them into Italy and into other parts of Europe. And that was really, for the first time, we had the scriptures in Greek. We had it was really a major propellant to the Renaissance, which took place in the late 1400s, early 1500s, and so on. And I think Plato's works were part of that. They were definitely held in those places. I also did a little bit of looking up, and there was Platonism in the Renaissance period. There's a guy in particular, what's his name? It was called the Second Plato, George
Platanos.
Gemistos Platon, who was in the 1400s. And so he was proposing a lot of Platonic ideas long before the 16th century, is my point. And so I don't know. I'll dig further into that, but I think Plato's ideas were known and it was a major part of the Renaissance. It was bringing those ideas into Italy and other places in Europe. Anyway, I couldn't find anything about 16th century. But anyway, there you go.
Well, we can see that the church has stopped being built a certain way then. So I think that's the timeline when it changed.
Well, what my subsequent research has determined, I had found, just one angle until last fall. Now I've figured out that all the steeples have the golden ratio in them. But I've even done some more recent research now, and even contemporary church steeples seem to follow the path, even though they argue that the geometry is just that the golden ratio isn't involved, and it's there. So I don't know if they don't know, or if they're trying to hide it, but it's there.
Well, I think it's fair, Charlie, to say that there was, until the early 1800s, we were taught geometry in the style of the Greeks. We were taught to draw things out and be able to construct angles in certain ways. There was an appreciation for all of that. That frankly has nothing to do with whether they were sacred or not. It's just the way the Greek method of teaching geometry was around for 2,000 years or more. And I think some of the things that were part of that school of thought have been lost. I don't ascribe any motive, like evil motive to it necessarily, just that maybe that we just kind of thought, oh, well, that's all old stuff. We don't need that anymore. And we've kind of thrown it away.
I'm sure there was an evil plot
Or
behind
there's
it
some of
somehow.
that at least. Maybe there was some evil motives too. I don't know.
Well, here's an interesting church. It's probably the most recent cathedral. I remember it was finished. What's playing?
Washington National Cathedral. Yeah, that's
Does that have the angle up in the top
that's
there?
That's the 27309. Yeah.
There you go.
Yeah, or 76345, however you want to talk about it. Yeah.
All right. What's that music? Hold on a second.
It's ethereal.
Was that Jeopardy?
I don't know. That was on DuckDuckGo. All right, but that has the angle there too. So on
Yeah.
their other steeples. Okay, so that was just finished. A couple decades ago.
Right.
Yeah, we
It
should be
took
able to
100
ask the
years.
guys, why did you choose that angle? Can't we go find
Well,
the
they
architects?
designed it 100 years ago, so I don't think
Okay.
they're around
So
anymore.
let's-
Yeah.
Okay.
But it's in the minds of architects and designers. It may not be, it's certainly not required anymore, but it's beautiful. It should be required. All right. So I'm interested particularly in the ancient structures, and
Yeah.
you had a little bit in the documentary. Do you have some images to share? It might be easier to flip through there than the documentary. Otherwise, I can pull it up. And some of these civilizations that you were talking about there, they're
Sure.
implementing the angle there tens of thousands of years or so. You're saying
Yeah.
3,000 to 100,000, somewhere in that ballpark.
Yeah.
Can you
Yeah,
go ahead and
well,
pull them up?
Yeah. I'm
Are
gonna
these in
pull
Turkey?
that up
Where
now.
there's a number of them around the world, actually, you were talking about.
Oh, there are. I'll pull them up. Give me a
Okay.
second. I'll pull up another slide presentation here.
Okay.
Let's see what we can do here.
That middle one would be cool to animate, to have the
Yeah,
little
definitely.
spirally thing going around.
Yeah.
I might be able to do that for you, Charlie.
Oh.
Ooh, well, that could be
Pet
cool.
project.
Just thinking,
Yeah.
just having the spiral swirl around.
Let me see. I'm having difficulties here getting this thing to shut down.
Well,
Why won't it let me?
let's
come
let's just
out?
stop sharing. I'll go to the video. I know where it is.
Okay, cool.
All right.
All right.
Okay, let's see. It's at the very beginning of your
So I'm curious, John, how is this all, are we like blowing you away? Are you staying with
It's
us?
fascinating. I mean, I'd like to see the ancient stuff, and it might be like it worked then, and then they followed design.
Yeah,
throughout.
yeah, these are the
Revisionism
Naragis
of
he's pulling
history.
up. Yeah.
All right. Well, let's watch a little bit and then we'll talk about it. I'm trying to get to the first one. All right. How do you say that? Naragi?
Noragi, I think.
All
Yeah.
right. So there's the
love that
angle there.
sushi.
Let's go ahead and let's go ahead and play that and see. There's the angle. Let's kind of skip through. So. And then the Great Zimbabwe ruins.
Function from Russian pyramid.
Let me
A
skip through
point
here.
A or picture A to B to C.
Now, do
You
the
can
Egyptian pyramids follow the
see- you
same?
can see these 13.
They have the golden ratio all over it, John. Yeah. It's,
Yeah.
That's way before anything. It's obviously passed down from aliens.
Well, they have. It must be. There's no other alternative.
Obviously.
All right,
Obviously.
so it's basically it's going on. All right, so well, now they don't even say obviously, they just assume it and go on. from
And-
there. All right. So all right, I have this theory, and I'm gonna pull up an image of why I have the theory. So I spoke earlier that there's many different ways you can fundamentally define the golden number as a ratio, as a proportion, as an analogy itself. But there may be something in it because it brings up the whole free energy and the structural basis of it, and that it seems, and with the sound amplification, it seems to always be self-reinforcing.
Mhm.
So, and I'm going to show you a picture of an egg. Greg knows this image I'm going to show.
Mhm.
But do you have any information on that, on the self-reinforcement properties of this ratio? Go ahead.
Yeah, yes. Boy, but you're catching me off guard.
No, not Greg. I was asking Charlie, but
Yeah.
Greg,
Well, yeah, no, let's hear what Greg has to
No,
say.
I
Let's
I
all
had some
discuss
stuff
it.
I did on the egg a while ago for you,
I can
Charlie.
pull
Yeah,
that.
I
I'll
know,
pull
I
that
know,
image
but I
up.
don't-
Charlie can speak to it as Greg researches it.
Well,
Yeah,
He's fast. He'll have it done in.
We'll
All
see.
right,
I'll
30
come up
seconds.
with
I'll
something.
find that image, Greg. You can go
Go
ahead
ahead.
and you can.
Oh,
Yeah, I'll show. It's just
you
one
play
image.
what you're
We-
playing. I'm going to do some digging.
Okay, go for it.
Okay.
All right, go ahead,
All right.
Charlie.
well, restate what the question is again, please.
It seems I mean, this seems to be that there's all right. So we were talking about there's many properties of this golden number. It's a mean and extremes. It relates the extremes of to a mean. It can be thought of as an analogy. It also can be thought of in terms of its reinforcement properties in
Right.
sound amplifications. So if you got a wave and it's going at a certain trajectory, it can be reinforced at a certain angle, a
Well,
certain trajectory
I mean,
with this number, and kind of help create a self-sustaining system or a self-sustaining wave in structure, in blocks, in bricks, sound waves. There's many different properties with this, and I'm wondering your
yeah,
thoughts
you
on that.
know, quite honestly, Jeff, I've been working on that for a couple of years, and I
Uh-huh.
came up with something. I showed it to Greg. I'm not sure Greg
Yeah.
perceived it, and others don't understand it. So maybe I'm not, but there seems to be. I put together a simple spreadsheet. I could send it to you guys if you want. I'd love feedback, but I'm just trying, it seemed to indicate that this geometry is the only one that will allow for um, uh, positive wave interference. Because
Yes, yes, this is
seems to
exactly what I'm
be,
talking
Yeah,
about. You got
that's
it.
what
yeah,
the
it
egg is
seems
all
to be
about.
Yeah.
the way that in a let's say in a certain, if you're moving in a certain dimension, that you can get all of the waves to connect at the same places. If they're out of phase, then you're going to have negative, you're just going to have incoherent garbage, but it seems to, but I haven't proven it out yet, Jeff,
Hmm.
and that's
Hmm.
so it's a work in progress. I'll just leave it at that.
All
Jeff,
right,
I got
yeah.
this. I found it. I got this. I'm
All right,
not sure
show
how to
me.
show it
Show
I
to
me.
knew
you.
you would.
Just
But,
share the screen. Just share the screen.
Okay, yeah. How do I do that?
Or you can
Shut down all.
speak to it.
Well, no, you gotta see the images. It's cool. So if you think
Hang
so,
on, I'll do it.
an egg turned vertically, it's like 1,000 times
Yeah,
stronger than turned,
this thing is called the
laterally.
geometry of the egg, and it has phi all over it. I got this file from you, Jeff. So
Yes,
this
I know,
is,
but I couldn't find it just now. So
yes, I
I was
got
gonna
it. But
pull.
okay, hang on. I'm trying to figure out how to share my screen.
Phi
Yeah, I was having
everywhere.
the same problem.
Let's see. Hang on. Okay,
Is he a
uh,
co-host? I hope. Yeah.
yeah. No, I know I've done it before. It's just I'm good at wasting time.
There's a green
Let's
button at the bottom in the
share
middle.
screen. Okay, there we go. And I guess I'll share screen one and share. Okay, can you see it now?
Yeah.
No, but I see all your research and I'm
Oh,
stealing
that's
it.
the wrong one. Okay,
Oh.
let me bring it over that one. Now
It
can you
must be
see it?
screen two.
No.
And
I see
minimize
what I
everything
do.
else.
Now
Minimize
you
it.
should see it. Yes?
Yes,
Yeah,
there it
we
is.
see-
Okay.
yeah.
Okay.
Yep.
There's the
Yep.
That's
egg.
All
that
right.
is so the geometry of the
everywhere.
egg. I mean, picture says 1,000 words, so you can see
Yeah.
the number phi is 1.618. So phi cubed is roughly it's close to the square root of 5. What is it, Charlie? It's 4.2. Yeah, square root of 5 plus 2. That's what it is.
Yeah.
And all the other numbers you can see the number 1 is that's how much above the circle the egg kind of goes. That's the number 1. And then the width of it is 2 phi. We see the number all over the place just in the construction of the egg.
All right. Where's the angle in there? I had another image with.
Oh, no, the angle, Charlie's angle doesn't show up in this.
But we could probably find it in there just by looking at a couple points.
Maybe you could. Let's see.
It's
The
tough.
triangle that we care about is going to have well, there's a couple of different ones. It's going to have a phi. It's going to have 1 on the top and bottom, and then it's going to have phi on the side, and then whatever it has to on the other. That's going to give you that angle, actually half of 76,
Yeah.
which 38 point something or other.
I think you have to take a line tangent to one of those slopes on the outside of the
Yeah.
egg.
Yeah,
Well-
no. I think let's see. Gosh, yeah, okay.
I thought maybe we'd
The,
obviously
the-
see it. We'd have to search for it for a bit, but yeah.
Well,
Well,
I think so.
let me ask a question, Greg.
Yeah.
You've got 2 triangles coming, one on the right and one on the left
Mhm.
of center, which look very similar to Giese geometry. Do you
Yes,
know?
they
Yes,
do.
I see that. Yeah. Mhm.
Well, then the 76,345
It's in
will
the
be
Giese
top.
geometry, yeah.
Well, it will be the top angle of the Giese geometry, and
Yeah.
probably would see it also in the one going down to the bottom, below the line, the center line. that larger triangle in the middle. So maybe
Okay,
there's
so-
still, well, actually, there might be two of them there. Yeah.
Yeah, well, I mean, so this right here, that's just going to be a 45-degree angle. That
Mhm.
that angle.
Is
That's
it?
a circle.
Yeah, it's a circle, so it is. Yeah.
So I'm looking for something like this.
You
The
could take
base
the
would be on the
point.
bottom of that, something like that.
Yeah, so I was thinking the same thing. Go above the line. You got 2
Oh,
points.
where this dot is. Okay.
Focal.
So
The
from
foci.
here to that dot, is that going to
Yeah,
be?
that's
That's
the
going to
pyramid.
this angle will be 57, but the apex angle, that's the angle that goes from
Yeah.
around the dot. That should be your 76
Yep,
degrees.
that
Is
would
that
be-
right, Charlie?
Yep, that would be right. Yep, that one. And I was thinking also the smaller ones. I can't point. with
So
my
you
cursor.
have to imagine a line drawn from this dot to that dot
Yeah,
to that
okay,
dot.
okay.
And then the apex is the angle on the top. This angle right here, that's the 76.
All right,
And that would be
I'll
the
check it
Giza
afterwards.
pyramid.
See what we can label it on. I'll put an image in
Yeah.
there. All right, now good. Go ahead and stop. Share real quick.
Okay,
All right,
sure.
so then the interesting question is, all right, so if that shape somehow of the egg it makes it so strong that they make cathedral, on the inside, the cathedral domes that shape as well. Greg was kind of which is why I shared that with you, because there was a study into that. Why are the cathedral domes built that way? Because they're strong. They're like designed off of the egg, in a way. It is peaceful. The sound is like warm, when you're standing under those big domes in that shape. And but I'm interested in the self-reinforcement properties of that,
Well-
because you're turning a thin material of an egg sideways, and all of a sudden now it's 1,000 times stronger. Then
Well, yeah.
that's pretty fascinating just from a simple number.
Well,
You were going to say something. Yeah, go ahead.
yeah. I mean, what I would love to be able to do at some point is to find somebody with a wind tunnel or a water tunnel where we could actually look at these geometries and see what happens in a real world testing environment. I think we could learn tons from that, but got to find it.
Well, you were even mentioning something about that in your documentary about the
Yeah.
aerodynamic properties of this number.
Well, that's right. That's right. I mean, one of the things that I'm trying to figure out, I've been looking for, and Greg, you may know something about this. I would love to talk at a experimental or theoretical fluid dynamics seminar and give my presentation on this, if you can figure out a place to find it. I found a list of, like every fluid dynamics conference in the world, but they're all going to require engineers, and maybe maybe you should be the guy doing it because you have the engineering degree. I don't know.
Well, yeah. Well,
I'm serious. I'm serious.
Yeah, no, I agree. We what what we need to do is give a theoretical reason why these angles are preferred. And that's what I'm still working on. I mean, it's fun to make diagrams and stuff like that, but it's like, why? Why is it there has to be a physical reason? It's one thing for architecture to copy nature, but it's another thing entirely for nature to prefer like tornadoes and
Yes, exactly.
whirlpools
Absolutely.
and leaves and all these things that prefer these angles. That can't be coincidence. There has to
Well,
be a reason.
But
So
but
that's what
neither,
I'm into.
yeah. Of course, that's why it was so fun to find this angle and these ancient artifacts of aeronautics.
Mhm.
I were you on that month? I think you were.
Yeah, we talked about a lot of
Yeah,
stuff.
yeah, but I mean,
on,
I've got pictures of a whole bunch of ancient aeronautical, statues and the Vimanas. From one of the models of the Vimana, you find this geometry in there. So
Mhm.
why did that happen? They knew about this,
Yeah.
thousands of years ago for aeronautics too. So
Well, can we look at that video on aerodynamics, or did somebody want to?
yeah, sure. Let me,
Let's see if we kind of want to go over in that really quick.
yeah, well, let me, I'm going to incorporating
What's that? You're gonna what? All right, that's fine. Okay.
the 76. Okay. Yeah. Oh, here it is. Okay.
Yeah.
You got,
Angle of sails.
here are Native American arrows, both the arrowheads and the fletching used the 76.345 geometry. So the Native Americans obviously knew about this information as well. And here's an example with bullets. Every bullet that I've measured ends up having this geometric angle as well. Here's the United States Space Shuttle. It's now retired, but it has this geometry. The Sputnik spacecraft, this was the first orbiting spacecraft, has this geometry. And here's the SpaceX Dragon. This is from SpaceX. Another example of Elon Musk using the 3D phi scaling geometry in his technology for spacecraft. Here's an example from India of aircraft that they are developing that use this geometry. Here's some of our old rockets, the Redstone rockets, which were developed, I believe, in the 1960s. Here's the Saturn I rocket showing this geometry. Jupiter rockets as well, having this geometry. Here's an example from Pakistan. And a couple of missiles here from Russia. These are American missile systems, the AIM systems. Here's a joint project of a missile system between Israel and the United States. Here's a Chinese missile system using this geometry. And here's some aircraft. This is the Lockheed SR-71 Blackbird. Has this geometry in its nose cone. McDonnell Douglas F-15s have this geometry in their nose cones, as do the MiG-29s from Russia. So everyone knows about this geometry. It's just that it's hidden from us for general public consumption.
All right.
Can I, Charlie,
Yeah.
I'd like to just throw in that, well, first of all, you got a lot more than just church steeple. But I mean, a lot of this is, these are engineers and they've spent, millions and billions of dollars coming up with the angle that cuts through the air the best, the most
Yeah, I think they're
efficiently.
finding it. I think they're
And
finding it.
they're discovering it rather than,
From simulators, yes.
coming at it
Well,
from
that's
first
right.
principles.
That's right.
And maybe you're the one who's connecting the dots and say, hey, this angle isn't by coincidence. It has to do with phi and all that
Right.
kind of stuff.
And
And they're
that's
not
the
even,
point.
they're coming at it from a completely different point of view.
Absolutely. And that's, to me, and just to finish up on this, I don't know if I put it into that documentary, but I've done work on hypersonic vehicles as well. Now the Russians know about this geometry because it's in their pyramids, and I would have, but their hypersonics work, and they're all designed with this very geometry in mind. Now ours have not worked, and maybe they're working better now, but we didn't use this geometry. And the last test we did about 10 years ago, they all burned up in the atmosphere. And I think it's because the coefficient of drag was just too high because they didn't have the geometry right. So, I could save people billions of dollars. I don't want this going to blow up the planet though. But, the idea is, you're right, Greg, they figured it out. They've just sort of
Trial and error.
found it by accident, so to speak, not on any sort of theoretical basis. And I would love to be able to get to somebody in computational fluid dynamics and say to them, look at all these examples. This is based upon a theory that I think you could model and cut down your research time and cost dramatically if you were to incorporate.
I think you have to have a reason of why that is, because it couldn't be atmospheric dependent, right? So otherwise these rockets, the atmosphere changes, especially as you go from lower Earth to the upper atmosphere, but the rockets still work the same, cutting through at the same. Why would it have why would it travel through there smoother? That's the thing I don't understand. It's got to be something to do with some reinforcement in a negative way as well. So it's cutting through. It's
Well,
it's not having as great effect on the air. Yeah, go
I,
ahead.
I mean, all I can tell you, Jeff, is I started to put together a model which links the torus, the Fibonacci series, and this universal phi scaling phenomenon all inside the torus, along with the scaling of fractals, and it all fits mathematically.
All right, let's get into that then.
Yeah.
Can you tell us a little bit about the model?
Well, I mean, what I was able to determine after I saw this geometry in so many different places, one of the places that I found it was in the Mandelbrot set. Using that kind of, that's where I'm getting this idea from, is that when you look at the Mandelbrot set, there's a really, the really tiny dots, and then they get bigger, or circles, excuse me, bigger and bigger. Well, when you measure the diameter of those dots, it scales by phi cubed. So that just happens to be the very same scaling geometry that we're using here as well. So I haven't, but when you put that together, you find also in a perfectly spherical torus that the horns of that torus have that same geometric angle of 27,309/76,345. What's the other thing that's really important? Oh yeah, George Leoniak, who is a sacred geometer, contacted me, gosh, 2 years ago now, maybe more, and we struck up a friendship. And he had seen that I had noticed these similarities between the scaling of the Russian pyramids and the Platonic solids. So sure enough, he's drawn that now, and this has been an ancient, theory for years, that the Platonic solids morphed in some sort of a, progression, and that they were intimately involved in the process of scaling. And sure enough, they fit like a glove inside this geometric angle. So
All right,
there's
Greg.
lots of
So,
pieces
oh,
that are
sorry,
puzzle.
I thought you stopped. Go
No,
ahead.
I'm
Sorry,
done.
it shut off a little bit. There was like a little hiccup in the audio. Finish what you're
Well,
saying.
this might be a good time for me to jump in, and Charlie, you've seen these before, but I did several diagrams for you, and
Sure.
I collaborated with George as well, and I got a lot of
Yes,
ideas
you did.
from him.
Most definitely.
If I could share my screen, I think it'd be appropriate to take a look at those now. They
Yeah.
kind of show where these angles come from and how to construct the pyramids and stuff.
Yeah. Yeah.
So let me quickly do that. I know how to do it this time. Let's see. There we go. And share. Can you see it okay? Can you see this?
We got your family
Back to
tree
your,
again.
family
No, you're kidding. Jeez. All right, let me try
Something's-
again. I thought I got it
tree. We
right.
need
this
to
time.
know your family tree.
Did I see the town
I'm so
drunk in there,
sorry.
Greg? No.
Okay, now I'm pretty sure I got the right one now. Do I have the right one now?
Yes.
Yes.
That's it.
Okay, I'm
This we were
sorry,
work-
that took
I
so
remember.
long.
I've seen this before. Yeah, we were talking about this.
Okay,
the
yeah,
other
I
day.
know you've seen this before,
Yeah.
but I just want to quickly show to John, since
Yeah.
John's never seen this and is not really a math guy, how this is constructed. Basically, what you do is each of these circles is exactly geometrically the same. The ratio between one and the next is the same as that one and the next. So it's kind of a Fibonacci sequence. And each one is 1.618 times further out than the last one. Okay. And then I drew this special dotted circle, which we'll call that radius 1 with the dot in the middle. That's the center of that circle. And then when I connect with the red lines to from the top of the larger circle to various points where they intersect, the smaller circles in between, I get those different ratios. So you'll see right down here, 76.345. That's where that one comes from. But it's also true that this golden one, this golden apex, you may have seen Charlie would draw a pyramid one way and then say there's the other one, the opposite.
Yeah.
That one has an apex angle of excuse me, the top of this angle, that's also 76.345. So we see that angle a couple of times in this, but this is the way to construct that, and you can kind of see how to do that. And then for fun, I did this one, which I thought is kind of some eye candy. Just have those circles just expand, and you see each of these red diagrams is a Giza pyramid. It has that angle in the apex, 76.345. And so we just keep seeing that over and over again. So kind of a cool little thing I thought you'd enjoy.
Nice.
We kind of talked around a lot of the stuff, you know, maybe give us your history in the whole thing. You said that you started 5 years ago and you first noticed the phenomenon with all these steeples, but then you kept finding them everywhere else. It's like you dream about these things. So
okay.
maybe a history of how you got where you are today.
Yeah, the chronology starts with the pyramid. I figured it out there and reverse engineered that. Then I noticed that the Giza pyramid apex angle and the Russian geometry slant angle is identical. So, but the next step that really started this, a guy from the Netherlands wrote me and said, "Hey, have you ever looked at the Hindu temples?" And I said, "No, why would I? I had no idea." So I looked at them. Sure enough, they showed up. And then, it was just one of these things. And one of my viewers wrote me and said, you showed the Tesla Wardenclyffe Tower, and you showed the Lesser Key of Solomon. They all have this geometry. She did an overlay. And so I said, wait a minute, this thing fits like a glove onto so maybe I figured out a design that Tesla was working with. I don't know. But anyway, I found Tesla. Of course, I knew that there was free energy in the Russian pyramid. So I started doing research into finding this geometry in free energy applications. I found it there. A friend of mine, it's just coming from everywhere. A friend of mine in Nebraska sent me one of Michael Tellinger's newsletters from a couple of years ago, and he was talking about his research on the Great Zimbabwe. Well, that's why I put it on the front cover of the book, because he said they measured the ionization field there, and it was the highest of anything like that they'd ever measured. And of course, they related in a video that research from the University of London, which corroborates that of the Russian research, in the presence of a large ionization field, viral load inside your body is reduced by about 99%. That's why I haven't been sick in 7 years. It all starts to come up. So I started to find it there, but then I found it in church steeples. And then I started looking in headwear, and, it just keeps expanding and expanding and expanding. So then I started finding it in fluid dynamics. I started finding it in more recently, I figured out all of the steeple angles, with this. So it just, one thing leads to another, and it's, it just keeps taking me in new directions. But, once you're into it, you can't not see it anymore. I found it in a drill. I was playing a game on my phone the other day, an app, and one of the ads came up with a drill bit that you can use to like act as a wood cutter or wood splitter, and it has this very geometry in it. Well, and it works like a charm. So, you just find it everywhere.
Are you familiar with the composer Robert Schumann?
Sure.
Did you know he ended up in the psych ward because all he could think about was letter A? I think you're going to find you one day going 76.345, 76.345.
Well, that's it. Once you see it, you can't
We'll be watching out for you. Just make sure you're okay.
Yeah. But I go down the road now along the interstate, and I look at, or wherever, look at church steeples. Oh, that's 5 to the 6th. That's 5 to the 4th. That's 5 squared.
Is the letter A got the 76 in there?
Well, it depends on, I'm not kidding.
On the font, right?
On the typeface. Yeah. I've looked at it, and it does depend on the typeface.
We should pull up your family tree, see how well you're related to him. Okay. Ionization field at the base of the structure. You had mentioned this documentary. You mentioned again. I'm not familiar with this. I certainly know how ionization fields can have a positive health effect because you're getting rid of free protons and all that. But why is it happening at the base of some structure? And you said it's a Russian structure, is that correct? What do you have a picture of that? I'm not understanding how.
Jeff, the diagram I showed you had the Russian triangle in it.
Yes, I'm familiar with the Russian.
It's the third one down is what he calls the Russian one. You
Yeah.
want me
you
to pull that up
Yeah,
again?
pull it up. Let's look at the
Yeah,
Russian
pull it up.
triangle.
Hang on.
Yeah.
All right. And so if you, and this is a pyramid in what city? Or not a pyramid, but a structure.
Well, the diagram was of, I think,
I
well,
thought it was a building or
Okay.
something.
this
You had
is,
a
this
picture.
is,
Okay.
these are the
Can you see it?
geometries of all
Yes.
Yes,
six.
Greg, thank you.
Okay, so the
Sacred-
Russian triangle is the one that's labeled 76.345. That one there.
That's the
You see
Russian
other-
triangle.
That's the Russian triangle. The Giza triangle is the larger one. This
Got
one
it.
up here.
Okay.
Both
So
the
the
Giza
Russian
and the Russian have that angle in it, just in different places.
All right.
Yeah.
The question is then, is there ionization if I were to build in my backyard some, pyramid of that shape and I stand around the base, is it going to have ionization that I can detect?
Jeffrey, I think you're going to find it more at the top.
The top. Okay.
Yeah. I mean, it's going to be
So
everywhere.
then what I should do is
but
build
the
it here in my
highest
ceiling
point
and
of
come down this way.
concentration is going to be at the tip.
Just the shape itself is going to ionize the air.
Mhm. Yep. Yep.
Oh my. All right. This is the easy thing to test. You could just simply build it. All right.
That's right. And the Russian research indicates just an enormous ionization field that occurs as a result.
Why would it do that? How would you strip? Were you stripping atoms? The shape.
Should I unshare, Jeff?
Yes, please. All right, Greg. You got any ideas why would that be ionizing? If it's something that can be measured and I could easily build a structure to reproduce that, why would it do that?
Man, I have to think about that. I don't have a quick answer for you.
Neither.
I
Well,
don't know. I guess I'm not still sure, Charlie, exactly. Does that mean like there's more? What does ionized even mean? So are there like
And
more
how is it
electrons in the
measured
area?
and-
yeah,
Is
they're more, yeah, right. Positive and negative electrons.
Well,
Yeah.
okay, but
Is it positive
do
or
they
negative?
distribute themselves in some way? Is it more positive and up here and
That's
more
what I'm
negative down
thinking.
there? Or?
The research that, they just said that they experienced the high ionization field. They
Okay,
didn't
I
say,
get that, but I'd like to know more detail about what that even
I
actually
would
means.
too.
Me
I
too.
would
That's
too.
what I'm kind of focusing
Yeah,
on.
I
Before
wrote-
I can
wrote-
posit why it does that, I don't know. I need to know what it's actually doing.
well, I think we have to come up with a theory. And
Yeah.
again,
Well, I think experiment first. I need to
Experiment
see
first
it.
and
I
then
need to
theory
see it.
second,
Yeah.
because yeah,
well,
you
that's
can
right.
theory
Well,
all day long.
well, that's it. We have two samples, both with the same geometry and with both producing ionization. Now, it's not perfect, but at least it tells us there's probably something we ought to look at there.
Doesn't matter the material.
The material is important, yeah, but
All right.
in the case of the Russian pyramids,
Yeah, what's
they
it made
were
out
built out of inert materials like PVC,
stone? Oh.
fiberglass.
Or
But the Great
Fiberglass.
Zimbabwe had
of? Fiberglass.
crystal and stone rock of some sort. I can't remember if it's limestone or granite or what.
Well, the rock itself may have had some sort of, favored angles. That
Well,
might have
maybe,
had something to do with it
maybe.
too.
Yeah, could be. But
But
we
he's
do
saying there's
know
a couple
that the
different
Russian-
materials they used.
Again, we know the Russian pyramids created free energy and ionization. So my theory, and I would assume this is why Dan is adapting or adopting this angle for his implosion model, is that, if this is the easiest way to minimize drag, when the force is coming at the tip of the cone, maybe the same forces would help to concentrate with what you're asking, which is this positive, wave interference at the tip coming, being forced in from the top up to, or from the bottom up to the tip. So it would seem as though that, that would make sense. If one way it would cut through the air easily enough that you could compress it most easily with the
Mhm.
opposite. I
Yeah.
don't know that. but
I have
that's-
just a
Yeah.
simple question.
Go ahead.
We say we know the Russian pyramids caused this.
Free
It
energy.
is
Yeah.
free
Right.
energy. Where's the study that shows it? Where's the
Yeah,
experiment
I was going to ask
shows
that
it?
too. Good question.
Where's the study?
Well, you keep saying we
it-
know that it causes free energy, but I don't know that. I
Now,
haven't
is
heard
there
this.
something that we could Google, like Greg could Google and see, okay, here's the reference to that?
Well, you can go to the only place, and I'll tell you, this research was not allowed to be published in the West. All of this science was
Interesting.
suppressed or the research
I don't
paper.
speak Russian, so it's hard to do research on that.
Yeah, well, and yeah.
Sure, it's
I
translated.
haven't been able to find them yet,
But
but
what type of free energy? Free? Are things levitating? Are we getting electricity
they
flowing for
put
free?
they put capacitors. They attach
Okay.
capacitors to the top of the pyramid. They spontaneously charged and blew off up into the atmosphere.
Wow.
Okay, that's pretty cool.
So
right.
yeah.
Yeah. So all right. So it's doing something. All right. So it's something with the
That's what it
ionization.
says.
Reference of there'd be a reference of this experiment, or they would do it again, right? I mean,
I'm
just
sure they
before-
probably you could do it again today if we were at the building
Well,
or the structure.
that's what it would take. I had a pyramid
trip
that I
to
was going to
Russia,
try to
let's go.
test.
I want to be clear on one thing, and that is the shape, the Russian pyramid or the Russian triangle. That's kind of your term. That's not what they call it. Am I wrong in this? That's some. I mean, we have called that the Russian triangle or the Russian pyramid, but I don't
Well,
think they call it that in Russia, do they?
Well, I mean, in the West, they're referred to as Russian pyramids because the
Well, they
research
are. By
came from-
whom? Who refers to them that?
Well, I guess everybody in the industry.
I would
Oh,
say
really?
because they
Okay.
invented it, right? I mean,
I mean, I'll go
Okay,
back
I'm going
to
to look that up.
yeah. I mean, if you Google Russian pyramids,
Yeah, I am Googling Russian pyramids.
you'll get pictures of these pyramids.
It says pyramids discovered in Russia twice as old as Egyptian ones. Russian pyramid,
wow.
Wikipedia. Okay, there is such a thing.
All right. Can you
all
share
right.
your page? I would like to see some pictures of these. Honestly, I've never seen these.
yeah,
So-
let's see the Wikipedia page.
Well, I'm not sure if I'm
And then-
ready.
Oh, you do that. I'm
I'm
gonna
still
pull it up.
digging.
Greg
And-
or
and-
John, I'll get something.
Yeah. And there's got to be something where somebody tried to.
Well,
prove what
the
you're saying.
summary of all of this research, John, can be found on a website called GizePyramid.com. There's a scientist who's on that site. His name is Volodymyr Krasnoholovets. That's a mouthful.
There you go.
But he published, there's a long one-page article that gives the summary of all of these results, but that's the only place they could get it published because apparently, this was censored.
You want to see how bad censored it is? Look, this is what I get when I pull up Russian pyramid.
So with that as a lead-in, we'll start looking
I get images.
and we're going to.
Yeah, I get a whole
Sorry.
bunch of images too, and the
Yeah,
images,
but
I guess they must have the
Hold on, let me stop
Angle.
sharing.
some
Hold
of them
on.
have your name on them, Charlie.
Well, a lot of them will, yeah. Yeah.
That's funny.
All right. So all
Yeah,
I got-
if you just Google Russian pyramids and look at the images, you get a whole ton of them.
Yeah.
Although some of them are Giza pyramids, so they're not really. It's not.
Yeah.
It
But-
doesn't know any better. But there's also something called Russian pyramid, which is another name for Russian billiards. It has nothing to do with any of
yeah,
this.
that's what I
Yeah,
kept
that's
pulling.
what-
up.
And so that's why when you
Well-
asked me to share my screen, there wasn't really.
The
Sure
other
on that.
the other place to get information, John and Jeffrey, is pyramids, PYRAMIDS.RU. Now that's in Russian, and that's the site that Dr. Golod has maintained about these pyramids. It's in Russian, so you'll probably want to use Google Chrome to translate.
And he's
Okay.
alive today, or?
Yeah, he is. At least I talked to him about 4 years ago. I had one opportunity to talk to him, and that was it.
Do you have his email? Or
I don't.
it'd be
we
neat
st-
to get him on.
Definitely.
We can, I can look for it. I'd be happy to see. I have. Let me think. I didn't have his email. I had to go through his son. So I'll check if you want to try to interview him. Sure.
Yeah, because that would be a good part two.
I would
Exactly.
love.
Both
Yeah.
of you.
I mean, I'd love to be on with him too.
No, we could do that. We have room. We get the. It would work out very good. All right. So one. I have one final question. Then you guys can all ask your final question because we're getting close to that time. So
Okay.
on the structure, because I want to do it. All right. So is the Russian pyramid ionizing? Is it hollow? Does it have hollow sections? Is it just You know, like if I were going to I
You
mean, I could
are
look into it,
looking
but-
at the inside of one of the pyramids at my background.
Okay, let me look at your
that was-
background here.
Yeah.
Let's
So
let him talk.
the poles, the superstructure is made with PVC pipe, and the skin is made with fiberglass.
So that's actually very doable from a cost perspective.
Easy. Yeah.
Yeah.
But that's very, how big are they? I mean, I'm not going to build an exact replica.
Well,
but looks
that one,
huge.
they built some that were 22 meters tall, some that were 44 meters tall,
Okay.
and some that were smaller than that. They built 20 or about 30 of these, I think.
I'm going
Some
to
in
do it like
Europe and
on a small scale.
mostly in Russia and Ukraine.
All right.
Interesting.
John and
So,
Greg.
well, I guess my question to you, Charlie, is can you find for us this actual research you're talking about? Because I did a little bit of digging and I couldn't find
Oh yeah, I'll send
that
you back.
specifically
Yeah.
talking about ionization energy being higher and in what way it's higher and how they're
Well,
able to,
yeah.
load a capacitor and have it be flying off. I
yeah.
haven't seen that. I don't know where to find that.
Well,
That would be awesome.
You can go to my website,
Okay.
stargatepyramids.com.
Okay.
I have compiled all of the available information from not only that website, but a couple of David Wilcox books, some books that were done by the editor of most of Patrick Flanagan's books. Anyway,
I
I've
know
gone
him.
a bunch of different places. So you can go there and you can read the the information that I was able to find from all
Very
these
good.
sources.
Thank you.
And if you go on the header, you'll see Russian pyramid research. And so it's up in the header and it's there. But
Very
that's
good.
probably the best single source. Well, it is. It's out there because I've compiled it from every place I could find.
Because who else is intense about this as you? I don't think anybody.
I don't
You're-
think
you're the
anybody
number
is.
one guy.
Nobody thinks about the letter A more than him.
No, it's
We got
great.
the most beautiful letter A's. All right. John, do you have a question for the?
Greg kind of took my question.
Good.
Yeah,
Okay.
Sorry,
It's all right.
I'll ask a different
You
one.
can find. No. We gotta end it.
No,
So-
because it's important to.
Yes, it is. All right. So this is what we'll do. All right. So we're gonna try to see if we can find this researcher and have both of you back on because this is really fascinating. And I thought I knew everything about the golden ratio and just finding stuff about energy and ionization. I'm very fascinated. So
Yeah.
thank you, Charlie. It's really a pleasure.
Yeah,
We're gonna do
thank
this
you
again.
very
Hopefully in
much.
a
Thank
few
you so
weeks
much.
we
Like
can
it's-
find some
it's-
great stuff.
You're very observant, and it's been there forever through
Yeah.
nature and
Mhm.
everything.
It has
And it's
been.
just the correlation you're putting together.
Yeah.
That's right. That's right.
Extraordinary. Yeah, you're doing
And-
great work. You're doing great work. I love it.